And in this tutorial, we're going to be going over our remove at method. Now what the remove at method does is it removes the node at a certain position. Alright, so to get started, you can see that we have our linked list here. Header is pointing to the first node, tail is pointing to the last node, and size is equal to 4 because we have 4 nodes within our linked list. Now if you're wondering what these numbers here symbolize, it basically symbolizes the position. So this is position 1, 2, 3, and 4, or you could think of them as indices. So let's start talking about the cases that we're going to encounter. So case 1 is going to be what happens if we get an invalid position. Now what do I mean by that? Well, we only have position 1, 2, 3, and 4. Let's say that you want to remove position 5, for example. In that case, we're just going to return. We're not going to do anything because there is no node at position 5. And likewise, if we get a position of 0, since the starting position is 1. So anything that's less than 1 or that's greater than the size, we're just going to return. It's an invalid position. Now let's take a look at case 2. What happens if you pass in position 1? Well, position 1, we already know how to solve that problem, and we could call the remove first method. So if the user passes in position 1, we could just check if position is equal to 1, call the remove first method. Now let's take a look at what happens if the user wants to remove the last node. Well, if the user passes in position 4, what we can do to validate whether it's the last node or not is check if the position being passed in is equal to the size. If it's equal to the size, we could just call the remove last method. Now the reason we're using the remove first method and the remove last method to handle the first and last node removal is because the remove first method takes into account what header is pointing to. So it's going to automatically update what header is pointing to for us. And likewise with the remove last method. The remove last method is always going to keep track of what the tail is pointing to. So that's case 2 and 3, removing the first node and removing the last node. So now let's talk about the final case, case 4. What happens if we get a position of 2 or 3? What I want to do is actually remove the third node from this linked list. And in order to do that, we need to traverse the linked list. Now remember, when you delete a node, we just can't remove this node because this node is always pointing to the next in line. So how do I go from here, have 2 point to node 4? Well, in order to do that, we're going to have to keep track of the previous node and the node that we want to delete. So now let's set up those pointers. So now you can see our starting points. Prev isn't going to point to anything because there is no previous node at the moment. And current is always going to be pointing to what header is pointing to as the starting position. Now, in order to traverse the list, we need to loop. So the first thing that's going to happen is prev needs to point to what current is pointing to. Then current needs to advance to the next node. So we're still in the loop. So let's do this one more time. Prev is going to be pointing to what current is. Then current is going to advance to the next node. So now our loop should have stopped because now we're at the position, the node that we want to delete. Alright, so now let's think of this logically. Before I could say delete the current node, what does the current node have that the previous node needs? Well, the current node has a pointer to the next in line. So now I could say prev arrow next, which will give me this pointer, is going to point to what current arrow next is pointing to. So this should give us something like this. And you can see by doing this that our linked list is still intact and tail is still pointing to the last node and our header is still pointing to the first node. Now the last step is to obviously delete this node since we don't need it anymore. And from here, since we successfully deleted the node, what we can do is update the size. So now let's actually take a look at the code. Alright, so to start off, you can see we have our remove at method. It's not going to return anything, and we're just passing in the position, and the position being the node that we want to delete at a certain position. So we have our test cases here, case 1, 2, 3, and 4. So the first test case, check for a valid position. So to do that, I'm just going to come down here and I'm going to say if the position is greater than the size, and size being the number of nodes within our linked list, that's an invalid position. Or if the position is less than 1, remember 1 is our starting point, so it can't be less than that, then all we're going to do is just return, because there's nothing to delete. Now let's move on to case 2. So I'm just going to come down here, and it's going to say check if the position is the first node. So how do we know if the position is the first node? Well, if position is equal to 1. So I'm just going to say if position is equal to 1, what are we going to do? We're going to call the remove first method. So now let's move on to case 3. Check if the position is the last node. Well, before I move on to that, I'm just going to make this an else if statement. So check if the position is the last node. So I'm just going to come down here. I'm going to say else if. And how do we know if a position is the last node? Well, if it's equal to size, because size is always the number of nodes within our linked list. So if the position is equal to size, we're going to call our remove last method. And our last case is all other cases. Now I could use an else statement, but I'm going to triple check and make sure that the header does not equal to null. So I'm just going to say header does not equal to null. Now remember, we need to traverse to the point that we want to delete, and for that we need 2 pointers, a pointer to the previous node and a pointer to the current node. So the previous node is going to be initialized to nothing. We're just going to declare it. And our current pointer is going to be pointing to our header. Next, we're going to loop until we hit the node that we want to delete. So I'm just going to say for int I is equal to 1, because remember 1 is our first position. I'm just going to say while I is less than position, increment I. Now the first step, when we traverse, we always need to update prev to current. So prev is going to be pointing to what current is pointing to, and current is always going to be advancing to the next node. So I'm just going to say current is going to be pointing to whatever current arrow next is pointing to. Now this is going to keep executing until we hit the node that we want to delete. Now all we need to do is actually update what the previous node is pointing to. So I'm just going to come down here, and now I'm just going to say prev arrow next is going to be pointing to what current arrow next is pointing to. The next step is to actually remove the node from our list. So I'm going to delete the node that we want to remove, and then we're going to decrement the size. So now let's just scroll down to the main method, and let's actually remove a couple of these things, and let's actually test this out. Now from here, I'm just going to save. I'm going to open up our terminal. I'm going to change to my desktop, g++ main.cpp. So now let's execute it. And you can see that 2 gets removed from our list successfully. Now I'm not going to test to see whether the first node works or the last node works, because we already coded the remove first method and the remove last method, so it should work. And if we give a position that's out of bounds, it's just going to return. So this is pretty much it for our remove at method.